Andreas Ciroth, and yeah, I've been introduced already, and I will now try to explain you a bit Open LCA, which is quite similar to the whole webinar title, but this is somehow not influenced by me. I try to cover these points. Open LCA is, as May has introduced, an open source lifecycle assessment software. It has been developed by us since already 10 years. So for this presentation, it was also interesting for me to go back to the very early stages and see how it all started. Then I tried to quickly present the software, talk about the users, and then it's maybe also interesting to not only present the software, but also that it's an open source software. What does it mean? Does it mean anything today? And maybe how is that? What does it mean, especially for users? And a bit an outlook, but it's quite short. So how it all started? It really started literally at EcoBalance conference in Japan in 2006. We had here prepared a German project, so we are in GreenDelta here in Germany, and we had prepared a German project proposal for creating an open source LCA software that was somehow declined, and still I had this presentation, and then I presented this and said, yes, it's quite important to have open source introduced into LCA, because basically this is the two screenshots from the presentation. So at this time, basically you have always data that is somehow used for a model, presents and creates a result, and this result somehow supports a decision, and the software is mainly responsible for taking data, putting it into a model, and also to somehow see the result. And therefore, if you make the software more flexible, if you give users more flexibility and make this process to create the result more transparent, this is very important for sustainability assessment. And therefore, this makes a lot of sense to talk about open source in this context, I thought. And we had three main ideas to design really a high-performance modular framework for lifecycle assessment, basically as open source tool, create a programming community, and also build first modules for that framework. And yeah, it was a bit so that we really did not have any funding at this time. And I mentioned this also in the presentation, and somehow, a bit to my surprise, then after the presentation, several interested parties approached me and asked, oh, how can we contribute? And the first real supporters were, to my really surprise, Pre-Consultants and ThinkStep, or then PE International, so creators of closed source LCA software systems. And that was really the start. And since then, we have continued to develop OpenLCA since, meanwhile, maybe 15 different versions or so. Seen a really large and increasing user base and also broader use, which is, of course, really nice. And I'm quite grateful for that. And now I'm trying to, somehow explain a bit how LCA is today. It's really, I think, professional lifecycle assessment software tool, powerful, quite rich in features, and still free and open source. We developed this in Java, so you can have versions in Windows, Mac, and Linux operation system. And you see the website is openlca.org. And I just have some, it shouldn't be too promotional, but just have some points where what the software can do. One is that we try to somehow combine or offer different possibilities for create product systems, so like model life cycles. And one is that we do this in a graphical mode that you see here. The boxes are processed and you can connect them over a user interface. And the other is that we have the possibility to do this via a table here. Sorry, here you see the input-output sheet of a process. And you can also connect here in this input-output sheet the different process delivering products, and therefore build your network implicitly, so to say. We have sensitivity analysis, quite well supported, parameters in various level, ability to deal with multifunctional processes, and also, of course, support LCA calculations. If there are questions I see here, then I'm not sure how we deal with this, so I think they should be postponed for later. But may please advise. Results analysis, Sankey diagrams, import-export interfaces, and also scripting. One thing that I think is important for understanding results is that we have quite prominent sophisticated, if you want, possibilities to drill down the result. Here you see one example where you have the impact indicator results, and then you are able to you see the impact assessment results, and then you see, oh, this process, this is the P here, contributes to this with this amount, and then you see also these flows, elementary flows in that process contribute in the inventory with this amount, and this is the corresponding impact, so characterization factor, and this is the for each substance, and this is the impact assessment result. We have the possibility to see results on a local, on a map worldwide. I'm sorry. See data quality, can show data quality results also for different results that are calculation results. And then we have, so this is a bit maybe straightforward, but then we have also special features in the software that are a bit unique. One is the regionalized, or the possibility to model inventories and impact assessments in a regionalized way. So here you see biomes that we use as a shapefile representing biomes, and then we can, with this, calculate location-specific characterization factors that are not naturally limited by one country or so, but it's really then defined by the natural system, which makes the result much more realistic and also correct, if you want, than if you take only the, for example, the characterization factor of entire Russia or so. And we just recently implemented the AWARE method, which is quite an interesting approach and a quite prominent method to represent a water footprint in life cycle assessment, as you maybe are aware of. Here you see a bit that a quite small example where this is how this is applied in the case study in cotton production in for example, the USA, and they basically you need to then link a specific process here on the what you see here below on the map. So you need to define this process is happening here on this map. And it can be a state, but it can also be just a field or so, or one point. And based on that, the shapefile of the impact assessment is linked to this, and then you get the corresponding impact characterization factor and impact result. And that's obviously for water footprint quite changing over different regions. So therefore, there's you get quite different results when you have consider these regionalized models. Which you see, for example, here when you look at the table, these different, so the inventory is always the same, but the aggregated characterization factor is quite different across different regions. You see here US Texas compared to US New Hampshire, sorry. It's quite a different factor, and then also, of course, also quite a different overall water footprint result. Yes, and then as a second, maybe really special feature is that we are also able to address social aspects and perform a social modeling, so that it really is something like a sustainability assessment software. Here you see just one example where we show different social aspects for one specific process that are then also considered in the lifecycle assessment calculation if you check this, and if you want to see social assessments in parallel to environmental assessments. Last thing, calculation time is always an issue, and databases are becoming larger and larger, but you see here that we are, compared to other software, doing quite well. So it's possible in OpenLCA to model really large system in a considerable time and still have a somehow tolerable calculation time. And I think that's the last slide about this. So we always, of course, make comparisons to other systems too, and then for quality assurance, and see that we really get the same results or almost the same results in our calculations. Okay, that was a short run through the software. I didn't get any questions, so therefore this is postponed to the end, I assume. Now let's a bit talk about users and also collaboration. And it's a bit difficult for, I think, any open source software to really know the users, because basically every user just can download the software and then use it. And there may be some users where we never heard of again, but who still continue to use the software. But of course, some just download and forget this. One indicator maybe is our OpenLCA Nexus site, which we use to distribute data for OpenLCA. There we have more than 10,000 users, and we see how many times the software is downloaded, which is really quite often or quite frequent. And from my feeling and for what we get as feedback, we have users, universities, where this is often used for teaching, and this is really literally hundreds of different universities worldwide. Quite some policy and research institutes, especially in the US, the US EPA and US Department of Agriculture and other agencies have for some time or since some time decided to use OpenLCA. Quite some consultancies and quite few companies who start to use the software, but often only in parallel to existing established closed source LCA software. Yeah, and here you see something to show also the worldwide spread, if you want, of the user base. This is registered user visits to OpenLCA Nexus in 2017, and it's overall really something like 30,000. And you see that this is quite broadly distributed across the globe, and excluding us. So if it's here in Germany, that doesn't mean that this is mainly us, but this is really, these are other users. Good, then, yeah, looking at the other side, I think we have three main user groups, not by type, but by how they want to or what they're looking for. First, users who do not want to spend a lot of money, so who are just looking for a not expensive solution, which is also fine. Then users who need quite and like also quite advanced features, large databases, social or regionalized modeling or so, and then also some who really believe in open source tools. But the majority of LCA users, I think, is so far loyal to their traditional tools, but we see some migration or movement towards other solutions, but this is not the broad trend, if you're talking about trends here so far. And that was the user base. And yeah, collaboration, we use OpenLCA quite, or is an important part or aspect of the LCA system architecture used in US agencies, so use EPA and other institutes in the US, especially the collaboration features of OpenLCA. And we use, of course, OpenLCA in several research projects. Also, other institutes use that, and especially some are just calculation, but some are also software projects where OpenLCA is used as a calculation engine and linked into a web server, for example, or linked to another tool for exchanging data. But what I want to put here also forward is that we have so far, different from what I anticipated 10 years ago, really not really seen a contribution to the code from other parties so far. It's not that we didn't wish that, but this is really the solution. Therefore, it's here a bit in red. We are, of course, open to this, but on the other side, there are quite often attempts or offers, but then is by people who are not really programmers or who try to do this somehow, but it must be really on a professional development level, and that's not so easy to find. But hopefully maybe this changes in future. So yes, let's conclude with the promise of open source software. I think first, of course, it's free and open source, so it's really in the spirit of sharing knowledge and it's transparent. And therefore, this fits perfectly to a scientific and life cycle assessment type approach. Still, some budget is needed. So, of course, it's a professional tool. So this has costs for maintenance and for developing new features. And we get this here. I hope you see the screen, because for me, our icons are somehow in between. Maybe it's not better. But we get income from database sales, development support, and training, for example. I think this open source type fits perfectly really for public institutions like US EPA. But this is really we are in Germany, as I said, so in the EU, this is not really recognized. So in PEF, for example, which some of you have heard of probably, that's not recognized so far. Yeah. Good. Maybe to conclude, I haven't heard a warning that I'm over time, but it's maybe time to conclude also. I have no further text here, but just to present what we are thinking of. Two things. One is that we think it would make sense to also try to provide open source solutions for businesses. So this is, as I said, not the majority of our users so far, but having a mature and still at the same time somehow innovative and also powerful tool, this makes sense. And we see quite an increasing interest. So this is something we want to explore and expand in future. And also, I think because Chris is next, it fits maybe, we didn't have too much interaction with the not many open source initiatives in LCA and sustainability assessment so far. So I think this is also something that I would hope that we manage to somehow better coordinate and exchange, so that we don't develop something twice or so. But this is, of course, always, we have a different programming language, for example, so it's not directly that we can use things as blocks or so. But still, we haven't explored this at all. So therefore, this is something I think also we should explore in future. And that's end of my slides. I hope you somehow could take something out of it, and then hopefully we can also ask and answer some questions in the end. Thank you. And now, it's maybe your time again, or Chris?
Yeah, thank you, Andreas. Next, we will be welcoming Chris Mutel.
Yep, so hello, everyone. And thank you for your attendance. So I'm going to be talking about BrightWay, and it's quite interesting that Andreas brought back the history of OpenLCA, because BrightWay actually has almost an identical starting date. It was in the fall of 2006. But I think the motivation was slightly different. So when I started my PhD and I started working on something which eventually would become BrightWay, I was working in a project with a Swiss realtor, and they were interested in doing lifecycle assessment for tens or hundreds of thousands of products. And of course, this has been a dream of many companies over the last 15 years. Hasn't really happened in a systematic way, but what that meant for me was that there was no possibility of using a point-and-click interface. I really had to be able to control the program on a very low level. And also, I was just curious about programming stuff on my own, so I started doing something which eventually turned into the BrightWay LCA framework. And we very purposely use the word framework because the idea of what myself and a few collaborators are building is not to replace OpenLCA, which I think is a great tool and is appropriate in most cases. But there are some cases where you would like to be able to just break some of the assumptions of existing software or go in different directions, or and do that yourself because you're a researcher or you're a consultant that has a deadline, or you're just curious. And so BrightWay is also, it's free and open source. It's licensed under the BSD license, which is available for everyone, companies and individuals. It's a relatively mature piece of software, some more than 10,000 standard lines of code, more than 100 pages of documentation, but it's definitely not for everyone. So it's not a replacement for what Andreas was talking about. It's much more a framework where you can build your own LCA software. So the design goals for BrightWay, well, the first and most important design goal of BrightWay is freedom. And what that means is that there isn't a fixed database schema. There isn't a certain set of assumptions built in as to what it means to do a lifecycle assessment. So for example, you might be working in the world of EcoInvent, where each transforming activity normally has exactly one reference product, but you might also want to break that its assumption and be able to say, well, I'm going to define activities which don't have any reference products, or I want to be able to have multi-output processes in my database without doing any type of allocation. So there isn't any checks there. It's sort of similar to some type of firearm where, you know, it's very powerful, but it can also be used to shoot yourself in the foot. So BrightWay says the responsibility is on you to use this firearm in the right way, which is great for people who want to go in different directions, but of course it could be frustrating at some points. Another thing is that we do store data in a relational database, but we don't have a fixed database schema. What that means is we have sort of an extra field where you can import a bunch of other things. So in this example I'm showing on my screen, we have some additional information that came in when we were importing the data that we were interested in. I think this was data coming from some energy economic model, which had a different spatial resolution and a bunch of different types of technology attributes that we wanted to include. So you can include more or less whatever you want. And that can be quite helpful when you are doing especially interaction between LCA models and other types of models. Another thing about BrightWay is that what's really built into at least the part of BrightWay that manages data is that you want to be able to have completely self-contained projects. So every time you're starting a new paper or a new consulting project or whatever, this is a separate unit of work. You should have your own copy of EcoInvent, and you have your own copy of your LCA methods. And then you can switch back and forth, of course, between projects. But this is a way of knowing that your data is always going to be reproducible, because a project is a standalone directory, and that can be stored in something like Dropbox or other syncing services. So you can work with other people, but you can also just archive it, so you can always reproduce what you were doing in the past. So this idea of having projects and knowing that if you, for example, completely break EcoInvent in some way in a certain project, it's not going to have any effect in other projects, can be quite nice. Of course, we would like to also have relatively good computational speed, and that's important not only for just doing everyday calculations, but also important as a means of enabling people to do the vision of LCA, which to do an iterative design of your functional unit and using sensitivity analysis to understand what are the most important parameters. So in tests I did this morning, you can do a complete static LCA calculation starting from nothing in about 0.3 seconds using EcoInvent version 3.4. You can do using just one LCA method, you can calculate results for every activity in EcoInvent 3.4 in 2.5 minutes. And the latest Monte Carlo results are on the order of about 160 iterations per minute, again using EcoInvent 3.4. We're used to cheat there and use version 2.2 to show good performance and kind of brag about ourselves. But now, if you look at these two linked blog posts, they explain exactly how we're getting this type of speed, which is basically optimizing throughout the entire calculation chain. Finally, a lot of times what we want to do is we want to go back into our inventories or even into our background databases and make some types of data manipulation. We want to change things either for sensitivity testing or because we want to be able to better suit our database for the specific study objective. And in this case, I'm showing an example of how you can go into an activity. So systematically throughout all of EcoInvent 3.1, you can remove everything which is a consumer of kilowatt hours. So you just set all of these exchange amounts to be 1. So this is just a loop. It runs. It would take, I don't know, a minute. And this would be a way of doing some type of database meta-analysis. But of course, it's not limited to this exact example, but you can always sort of type what it is that you're thinking in. And of course, you need to have some degree of expertise in order to be able to build these constructions. But once you have that degree of expertise, once you have gone through the tutorials, then you're able to do some sort of powerful stuff. So BrightWay is written in Python, or at least most of it is written in Python. Of course, the numeric libraries we're using are in things like C or C++ or Fortran. And people have started writing interfaces between BrightWay and other types of computer languages, but Python, I think, is a very nice, especially nowadays, a very nice language to learn, because it's sometimes you can type the way that you would talk, at least if you're a native English speaker. But also there's very nice libraries such as pandas at scikit-learn. A bunch of machine learning is done in using Python, at least as a glue language, as a wrapping language. You can also model stuff in completely different ways. So I'm showing here the AB, that's the activity browser. That was a project started by Bernhard Stäubing, who's now at CML, which is a graphical user interface. You'll see some screenshots of that in a little bit. We also have the LCA project. I'll show you a brief video of that. That was a completely independent project done by James Joyce at KTH. And then we have Ocelot, which is an open source implementation of system modeling, and Wurst, which is a package to allow you to better document how you're going to integrate external data into LCA studies. So there has been, because, well, I guess there's a variety of different reasons why this is true, but we are lucky to be in a place where we do have people taking control or proposing different projects. And of course, it's open source software, so it's not like there's anything under control, under our specific control. So people have gone and just said, I have a need which isn't being met by the existing code base, so I'm going to do something. So that's, for example, the activity browser, which was initiated by Bernhard Stäubing, is now also being worked on by Adrian Haas at ETH. Temporalis, which is being worked, which is the library for doing dynamic and temporal lifecycle assessment, being worked at a PhD student, Giuseppe Cardellini. He's at KU Leuven. Presamples, that's being worked on by Pascal Lesage at the CEREG. The REST API is being maintained by Thomas Navarrete, who's at LIST, and LCA is a completely independent project being done by James Joyce in KTH, which he also got accepted to the Journal of Open Source Software. So there is a bunch of people buying in. The core code is mostly maintained by me, but there are a bunch of people filing either bugs or feature requests. So I'm going to show you just some brief examples of how people can take this sort of framework of BrightWay and go in whatever direction they want. Some of it is by myself, but a lot of it is now already by active external users. So for example, here's a video showing the LCA project. So this is James Joyce. He really wanted to have more of a graphical interface, and he wanted to have parameterized data sets. And so he went ahead and I'm not sure if I can, let's see if we can show this. Okay, go. Yeah, so built this software where you could kind of have a Gabi-like interface where you could also directly access the search for things, but also parameterize those exchange flows. And here he's not using BrightWay as a user interface to LCA software, but using BrightWay as the background calculation engine. Yeah, so you can see, if you search for LCA, this will also be linked in the presentation slides that will be shown later on. Okay, the activity browser, this is the project of Bernhard Stäubing, and this is an idea to see, can we reinvent the way, well, first, sometimes it's very nice to have a graphical interface to your data, but second, I think he also wanted to reinvent the way that we build inventory data sets, and in this case, there was a two-panel design where you would search for things, and then you'd be able to drag and drop them across. And because it was built in a very nice and modular fashion, it was easy to add in different types of LCA calculation results. So I don't have any graphics showing this, but Adrian Haas is working on, for example, interactive Sankey diagrams, and there's a bunch of other things you can do because we're building on top of work that other people have done, of course, and a lot of it now is being done in either Python or in JavaScript, which are both very easy to integrate into BrightWay in general. Here's another example. This is a paper that was just published by my PhD student, Brian Cox, and myself, and in this case, he scraped the web for a database of every commercial airplane built in the last 30 years, and then he was able to scrape the web for the actual landing takeoff cycles of airplanes and the routes being flied from Switzerland, and all this was being done in Python so that all of the data analysis and preparation was done in the same language as the LCA calculation steps, and so he was able to really do a systematic meta-analysis of essentially every flight coming to and from Switzerland for a very long time, and then also to do prospective life cycle assessment and just try to say, okay, here's my model of a current airplane. How can I change that so that in the future I have better material efficiencies? I'm moving more towards lighter weight materials, things of this nature. Another project being done by Brian, which is integrating results from an integrated assessment model, in this case the image model, which is developed by PBL, the Environment Agency of the Netherlands. And in this case, Brian also built a model of how does a car perform. So again, this was being done in Python. So you have driving cycles, you have a simple physics-based model of all the different sorts of resistance, and then you can do prospective LCA, integrate the future performance of electricity generation and other types of changes in the industrial economy coming from your integrated assessment model, and then look at what are the potentials of introducing autonomy and electrification in the transport sector. And because all of this is being done in Jupyter notebooks and being done in Python, you have this very nice interface between all the other work you're doing for LCA studies and the specific LCA calculations. And in this case, it's not just static calculations, but also I'm showing sensitivity results. So we're doing tens of thousands of Monte Carlo iterations. Andreas already talked about regionalized LCA. So one of the things that the BrightWay 2 regional library allows you to do is design your own methodology, calculation methodology for life cycle assessment. So you can look at the simple matching between, for example, two spatial scales. So you have a spatial scale of your impact assessment method and a spatial scale of your inventory method, but you could also have intermediate spatial scales that would tell you the relative intensities within those regions. So for example, you're looking at the characterization factors in Vermont or Texas or something, but of course we know that we don't have a uniform spatial distribution in these areas, so we need to have a third or even a fourth spatial scale. And so BrightWay 2 Regional allows you to redefine your calculation using these matrices, which actually are transformations from one spatial scale to another. And that allows you to, A, plot the results on any of these individual spatial scales, but it also allows you to get more accurate results in the sense that you're not assuming you have uniform spatial distributions in either your inventory spatial unit or your impact assessment spatial unit. And of course, because a lot of times we're working in Jupyter notebooks, then you can directly include the graphing libraries there and customize them for your specific study scope. One other thing you can do, which a lot of people feel very comfortable with, is you can build models in Excel, and then and you can do that with whatever level of complexity you need. You can have multiple different scenarios, or you can have a bunch of equations which are being resolved in Excel. But in the end, as long as you have one worksheet which looks like what you would expect as the old time, for example, input to eco-invent, then you'd be able to define, okay, here are my activities, and then in my activities I have this input and this input and this input and this input, and then you can import those, and you can even do this directly in the calculation routine, so that you never actually have to worry about, is the database current? You're going to make changes in Excel, and then you run your you run your notebook, and you produce your new result graphs. One thing that we've recently added in preparation for supporting pre-sampled Monte Carlo results is a whole chain of different types of parameterization, where we're keeping track of which parameters are stale, which parameters are fresh, and you can define parameters on the level of the project, the database, and the activity parameter. And you can also define which ones you want to activate or not. So this was rather complex, but we finally have this activity where you would store stuff as strings inside the database. Of course, in a lot of cases, storing things as strings isn't necessarily the best way. You would like to actually have an external model completely. That's in the two papers from Brian that I showed you before, where you also have this ability to, you really have a completely independent model, and it's only at the end that you input data into your LCA calculation. So that's the different types of case studies, giving you just a flavor. Of course, there are other things that people are doing, and I'm sure I've forgotten maybe even the most important or exciting ones. One thing which is nice for BrightWay 2 users is installation is much easier than it used to be. So if you look at the sort of the red dots outlining just one line, so now it's basically one line to install BrightWay, and that works, of course, on Mac OS and Linux and Windows. And here I'm showing you can install it, and then you can open it up and just type in from BrightWay 2 import star, or however you choose to import stuff. And you can, well, of course, you'd have to import your databases. It's not like you get Eco-Event for free, but you can get started quite quickly. So that's the end of my presentation, and I think the idea now is that we go to the questions.
Great. Thank you, Chris and Andreas. So we will now have a brief Q&A session, and thank you to those who submitted questions during the presentation. As a reminder, if you have questions, please feel free to type them into the Q&A box, and I will moderate the discussion. So, our first question comes from Adriana, and the question is it possible to save OpenLCA files in one computer and then use them in another computer? For instance, to work at your office and take files with you and then work from your home PC? And a follow-up to that question is, can you input negative flows when using end-of-life processes?
Okay, for me, I guess, yeah.
Yes.
Yeah, thanks. Yeah, good question. So first, I didn't expand a lot on the import and export features of OpenLCA. We support quite many different formats. You can export in ICD format, or we prefer our own JSON LD format, which is more maybe slim or not as bloated as the ICD format, but still preserves everything that you need for an LCA model. And there you can export processes, but also entire product systems, meaning model life cycles, and import them back again in another computer. But you can also make a backup of your database and import this database then when you're at home, for example. And then you have everything, so all the different elements that are in that database also in the other computer. So that's a quite common approach to use. But you can also use one of the formats that is used for import and export. And sorry, I forgot the second question.
The second part is, can you input negative
flows? Yeah, yes, you can. And this is in EcoInvent the usual way to deal with waste treatment models, because in EcoInvent as Chris has also introduced, the sometimes simple model is that a process always has one product on the output side. A waste treatment process has the product on the input side, and to preserve the mass balance, a common approach is to just say, okay, the product is on the input side but has a negative amount, so then the mass balance is preserved, which is of course a bit counterintuitive. Therefore, we've been now working on this, and in the 1.7 version, which we hopefully release this month, we are able to, we have a new type that is used, waste flow, and this waste flow is then, you can model this then just as the normal flow direction, so that the flow is an output of a process that is then delivered to a landfill or waste treatment site, for example. And then the software, before making the system calculation, knows, oh, this is a waste flow, and then it reverses the order internally. So the user doesn't need to do this, but it's just done before the calculation starts.
Great. And an additional follow-up question to that is, from the same person, which would be the best database for Colombia, since there's not much information for this country?
Yes, so that maybe depends a bit on the products that you are investigating. EcoInvent is often quite a good choice. In EcoInvent, it's quite generous, you could say, because normally it's of course a not free database, but for non-OECD countries, they offer for academic use a free license, and we have a special version for OpenLCA, or adapted for OpenLCA, and this is also, we make this also available for free for non-OECD countries, which is often a good starting point. But if you're more into more specific products, then sometimes more there are other agricultural, for example, databases, or in IT, we are now preparing a Japanese database which has quite some data sets on hardware, computer hardware. That depends a bit. Yeah, and I didn't put the link, I forgot to put the link of the Nexus site into my presentation, but if you Google OpenLCA Nexus, then you find our database site, and that they can search for different products and find the databases that contain these products.
Thank you. And the next question, how easy is it to modify the underlying code for OpenLCA to implement a new computational structure? For example, is it possible to specify the scaling factors of some technological modules to be 1?
Yeah, so it's our code is mainly Eclipse, Java as a rich client platform application, but we have, for the calculation itself, we use some numerical libraries which are in C or C++. But I think it's possible, and of course it's fully transparently available. And if you understand Java, then should be able to modify the code. However, I didn't fully understand the last part of the question, because to change the scaling factor of a technology, you wouldn't need to change the code of the program at all, but you can do this via the user interface.
Thank you. Next, Dr. Roberto Quiros from the University of Costa Rica asks, can we do the LCA by graphic model as Gabi or by SEMA Pro approach? And is that correct?
Again, to me, yes, both are possible. And indeed, I mean, it's not nowadays. Gabi is the most prominent software who has this graphical modeling, but previously there have been other softwares also existing, and yes, both are possible to apply. Of course, if you think of an eco-invent system with 10,000 connections, then it gets a bit long if you make all this manually, but this is also possible. Typically, we use a combination so that you have that you model your foreground system in a graphical way. And then we have in this graphical editor an option complete supply chain, and then the rest is done automatically. And this is then a bit like in SEMA Pro, which is then adding the thousands of connections if you're using the eco-invent database.
Great. And can you run a script in BrightWay to extract waste flows from all unit processes of eco-invent datasets?
I'm not sure what labels are provided to define something as a waste flow. So this is something actually that we were looking at just a few days ago to try to determine what actually was a waste treatment, because they're not always labeled as waste treatment. If you define what the filter criteria for what is a waste treatment to you, then of course that would be trivial. To define it as something which is a waste to eco-invent might be a little bit harder, because you'd have to maybe look for specific strings inside the comment field. But you can definitely loop over all of the activities and exchanges, find things which probably are waste treatments, export those, and then sort of manually go through and clean up the data.
Okay. And another question is, can you know in Open LCA or BrightWay 2 framework all unit processes datasets of a respective cradle to gate dataset?
Okay. Can you know?
Yes.
What do you mean?
Well, the direct question is, can I know in can I know in Open LCA or BrightWay 2 all unit processes datasets of a respective cradle to gate dataset? And if that question is not making too much sense, Raphael, if you want to just put in the Q&A a clarifying note, that could be helpful to the speaker.
One maybe quick answer is that we have an SQL, we have developer windows from the user interface, and there you can, for example, query the OpenLCA database that is active and extract all the processes with their ref IDs, for example, and other informations that are currently present in the database. You can also apply, of course, filter criteria, and then have this as a result as a text, and then paste and copy and paste and use this elsewhere. If this was the question, I'm not sure.
And next is, in the view of many, LCA has a massive transparency and reproducibility problem. So what could be the role of OpenLCA and BrightWay 2 framework in open science?
Chris, you first, or should I?
It's
a big question.
So I would say the contribution that BrightWay can make, and I agree that there are issues related to transparency, even in databases whose entire modus operandi is based around transparency. And the one thing that you can do if you're writing a research study using BrightWay is you can you can make it entirely possible for somebody else to reproduce everything that you've done by including either your Python scripts or preferably your Jupyter notebooks, where you would include notes on what is it you did, what you tried and didn't work out, so that people can download those and literally reproduce every result and graphic used in your paper. That being said, we do have deeper questions as to where the data is coming from, and even if you are using databases like EcoInvent, a lot of times you can find specific information, but sometimes you can't. So certainly I think there's the opportunity for people to come in and make completely transparent background data.
Yeah, very good and big question also. In addition to Chris, I can add, well, in OpenLCA you can of course also publish what you use for the calculation, and then this is also fully transparent. I think often, so there's the software part and the data part. We are both talking here about tools, so the software part only. And to my feeling, a large part of the intransparency issue that is, I would agree, also at stake, or the transparency is at stake, that the databases, even if they are unit process based, are so complicated and so that even there it's not fully transparent what is linked to what, and there this is maybe also due to not sufficient software support, but it's also because of the databases and the way they are structured. But then, of course, on the other side, you have many databases which are only aggregated, and there it's impossible to understand the details of the modeling and check them. But I think it was also part of my presentation that I think open source software is, of course, then is transparent and therefore can contribute to more transparency in LCA, but that's not everything. It's also maybe the software needs to improve a bit to make databases to make it better more easy for user to understand databases and their connections. Therefore, I think the OpenLCA project that Chris has mentioned and is involved in and is leading is very good. But also, to somehow maybe improve understanding that unit processes need to be used in LCA, and that aggregated data sets are really only second choice.
And Jose asks, is it possible to undergo a full LCA analysis by using only the free databases from OpenLCA Nexus? And is it possible to use several data sets or databases at a time in OpenLCA?
That also depends, of course. It depends on the goal and scope of your study. It depends also on the specific product you are looking at. There are some databases which are quite broad and which are free. But often you are aware of some flaws. For example, we have the German Probas database in Nexus, and there you see, which is quite large, but there you see that this is some data sets have really limitations, some also quite good, so it's more tricky, and you can't assume that everything is about the same quality level than if you use a full purchase database. But at the same time, we have also other initiatives that it's really then an open access way to use a database. We have been, for example, got some little payment from the Exiobase consortium to make the Exiobase database for free available in OpenLCA. So they paid for our few days of development or implementation, and now the database is completely free. And this is not, well, this has really created with care and also is maintained. So therefore, this is a database that I would recommend, but it's an input-output database, so it's different from a product-specific traditional LCA database. And the second part, you can, to some extent, combine databases. We are trying to do this, of course, but if the database has aggregated process, we can, of course, not change and make the consistent then the methodology that was used for creating the data sets. For others, this is well possible. So there's Archibalis who links or can link to EcoInvent, for example, because they use themselves. So ADEM, who's releasing the database, use themselves EcoInvent for modeling the background and so on. So in these cases, it's well possible, but in others, it's more difficult.
Okay. And next, OpenLCA and BrightWay 2 seem to have complementary features. Can they be used together?
Well, one thing I do know is that you can use Jupyter Notebooks with OpenLCA
Mm-hmm.
now.
Mm-hmm.
So there is certainly potential of developing inventories in OpenLCA, using OpenLCA for 90% of what you're doing. And then if there's some additional feature you would like, either working with BrightWay 2 or even just working with sort of the things which have branched off of BrightWay 2. Things like that would definitely be possible today.
Yes, I agree. And I think also we should maybe, we're all too busy, I think, but we should take maybe this also as an opportunity to after the call, catch up and try to find how we can exchange more on what is possible together. But yes, we have recently implemented Jupyter Notebooks for OpenLCA, and that is could be a nice one nice point.
Okay. And another question, is it possible to conduct a hybrid LCA analysis that integrates input-output tables and process LCA data in BrightWay 2 or OpenLCA?
Yes, definitely for both.
Yes, yes, yeah.
Wonderful. And Mehdi asks, a general question about open source software versus licensed applications is always about reliability. How do you ensure the users in terms of continuous support, help, and problem solving?
Yes, maybe I start. So that's a good question. But I would say that because we are somehow forced, or we force ourselves to release the source code, that we have we are also forced to develop the code in a more clean way and to reveal how the code is done, and so we have less possibilities to shortcut things or so than if you have a closed source software and the user doesn't really see how some things are implemented. I mentioned also that, of course, it's not so that because the software is free, we are not we are working all for free, but we of course have salaries that need to be paid, and we so far really managed quite okay to sponsor or pay for the project by database sales, by training, and also by direct development support of those users who use OpenLCA and think additional features are needed and maybe also need to be maintained. So that so far works, but there's of course not a full guarantee that this continues forever. But I think this is for any product not the case. So also for closed source software, you do not know whether this will continue in the next 10 years. I think also that the existing, so between us, so to say, that the existing LCA software licenses are quite expensive. So therefore, there's maybe not that amount of money needed to maintain the software.
Well, one thing I would add to that is not only do you see the open source code, but you also see the tests which are being developed to make sure that the results are what they are expected to be. So that's also a huge, I would say, benefit. I have no, this might be a little bit arrogant, but Andreas was showing that they're testing against CIMA-Pro. BrightWay doesn't test against CIMA-Pro. If CIMA-Pro has a different answer, it's wrong. I think BrightWay is 100% compliant with the way EcoInvent is supposed to be calculated. And if there are bugs, then we are filing bugs with the EcoInvent Center saying the data that you released had this problem or has these things which can't be fixed or whatever. But in the end, the math is simple enough that you have a guarantee that you're doing the right things, right? I mean, it's a supply chain graph. You have some nodes along some axis. You have some edges along the other axis. That you translate that into an adjacency matrix. You solve the matrix.
I agree. I can say it was an old example that I showed. But we still make tests against, for example, the EcoInvent aggregated process results that are published and compare and so on.
Okay, and with that, we have run out of time. So that concludes the talk on OpenLCA tools and trends. Andreas and Chris, thank you so much for joining us today, and thank you to all the participants for the questions. To view a recording of this webinar, please visit the member portal on the ISIE website, and you can also find it on the ISIE YouTube channel. With that, we conclude. Thank you so much.
Thank you very much, everybody. Thanks. Bye-bye.
Thanks from my side as well.